Now, the nice thing that with what we're starting with is that the coefficient of the x squared is just going to start out as a 1, right there, as a phantom 1, which is going to make things really nice because all we got to do is focus on these. This would be the constant, and that would be the coefficient of just the x. So what we do is we look at the factor pairs for C, not prime factorization. Don't get the two confused. Factor pairs for the C value, even if it's negative, okay? And we want to find a factor pair which, when we add them together, we get the coefficient of B. What that tells us is the two values that we need to separate this one into. Now that's if we were to factor by grouping. Once we show a factor by grouping, we're going to take a shortcut because once you find a factor pair from the constant that adds up to the B value, then you can actually just replace these into the two binomials. So it is a nice shortcut, but I'll try to relate it to factoring by grouping because eventually we're going to, once we have a coefficient of the x squared, we're going to have to factor by grouping anyways. So again, I'm looking at factoring by grouping, okay? And but I'll do this twice just because it really isn't too bad, right? Six doesn't have a lot of factors. So here's the way that I set it up, okay? So I say, look at 6. I'm looking for factor pairs. Now this kind of sets up, it looks like a factor tree, but I've split it up twice, specifically because I want a pair. And then I'm just going to list the pairs as I go down right here. Now, I'm purposely going to list probably more. Well, it is going to be more than we need, okay? But I want you to see that you have to consider all factor pairs when you go through this. But remember, I'm going to list them, and then we'll figure out which pair adds up to 5. And I think it'll be pretty obvious once we get there. Now, for 6, usually students will start out by thinking, well, 2 times 3 is 6. That is a factor pair. Factor is multiplication. What two numbers do you multiply to get 6? 2 and 3 works, but this is kind of a crucial one because it happens from time to time. 1 and the number itself. Okay. Now, some students would say, well, Sal, you're done. You don't need any more factor pairs, which is true. But again, I'm going to show them. And then some students are like, yeah, but there's not any more. There is. There is. Because if I were to make this -1 and -6, if I multiplied these two together, I would still get +6. Okay, so we need to consider not just the positives, which is usually what we do with factor trees, but now the negatives as well. So really it's the same list, just now the numbers are negative, okay? I'm gonna go through these as well. I'm gonna go through all of them because we're looking for one of these pairs to add up to the middle coefficient 5, right? So I say right here, 1 plus 6, boom, that's 7. Now I know that's not gonna work. And I'm purposely gonna skip the next one because, well, you'll see why. But -1 plus -6 is -7. And then -2 plus -3 would be -5. Now some students say, oh, look, you got a 5 right there. That's true, but this is a +5. Remember that all the terms take the operation to its left, and that's why I skipped that one, because 2 plus 3 is 5. Okay, so 2 plus 3 is 5. That tells me that the middle term, so this is what we started out with, x squared plus 5x plus 6. The middle term I can split up into those two factors, 2 and 3. This tells me how many x's there are. So what I just did right there is I took 5 x's and I split it up into two values that combined would give us 5 x's. Same value of 5x, I just wanted to see it different, which is usually, it's actually a huge deal in math if you can start to learn to make things do what you want them to do. Things turn out pretty well, okay? So that's what I've done. Well, the rest of the expression, we got the x squared, that was a +2x plus 3x plus 6, right? And now you see, I took that trinomial, and now that I have it into 4 terms, I can now factor by grouping. Well, if I was to factor by grouping, I would group these first two, and what could I pull out from those two? Looks like I could just pull out an x. Okay, fair enough. If I pulled out an x, then the first term would be left with an x, and the second term would be left with a plus 2. Okay, the second set, 3x plus 6, looks like I can pull out a 3 from both of those. And then the x just has to stay, right? So I pulled out a 3 from the first term, so I have the x. You can make it 1x if you want. And then the plus 6, I pulled out a 3, so 6 divided by 3, boom, 2. And I was expecting this to be plus 2, by the way, because this one was plus 2. So that's the beauty of finding the factor pair that adds up to the middle coefficient. It allows you to factor by grouping, and it'll work out very nice. So now that I have that, from those two terms, I'm going to factor out an x plus 2. And then the other set of parentheses is just what is left over, right? So I have the x from the first part, and then I got a plus 3 in green there from the second part. This is the factored form of this trinomial. Now, what I was trying to show on that last slide was pretty much at this point we could have been done. Once we knew that 2 plus 3 is the middle coefficient of 5, we could have just said, hey, look, let's set this up. Okay, that's what that last slide was saying. It's x, and then just put in the two factors, which were plus 2, positive 2, and positive 3. See, these are exactly the same, and it skips a lot of this work right here. This method right here, it's going to work all the time because sometimes there's a lot of rules, right? It's like, I can't memorize this crap. Okay, then just factor by grouping, which is, it's always going to work, including when the coefficient of x is not a phantom 1.